Hello students, how are you? The amount of beard is directly proportional to the number of our days stayed home, still lockdown. Well, today we are going to discuss some numericals, and honestly speaking, I'd like you to explore. I have given you the questions. Go through the questions. You try for yourself. You may not give a lot of time, but some time definitely you need to spend with the question. And still, if you cannot solve, then only look at the solutions. And if you have tried and you couldn't, then you can find the solutions here. I am going to solve the questions of 15, 16, 17, 18 of assignment 1.2 that I had shared with you today morning. The thing is, if you have not tried at all, then do not look this video. You stop watching over here only and go. You try for yourself for some time, and after that, if you are able to solve yourself, you will be delighted. That's a good experience. But if you can't, still, if you find the solution over here, then you will find nice only if you have tried. Otherwise, you may get the solution to a question only, but you will not improve as far as your brain muscles are concerned. That will not be developed. Okay, so let us take up assignment 1.2 and question number 15. Question number 15, which says, let us assume that charges on earth and the sun are not neutralized. So I'm giving you the question, so I'm not writing the question here again. What it says is, let us assume that the charges on earth and the sun are not neutralized and net charges are equal. Net charges are of equal magnitude and a similar nature. This is sun and this is earth. This is sun, this is earth. Net charges are equal magnitude. Let us say both are having charge q only. Okay. What must be the charge on each so that the Coulomb force just cancels the gravitational force? Let us say the distance between them is r. Okay. Now see, if both are of equal nature, then the force, electrostatic force, will be repulsive in nature, right? So sun also will be pushed away from earth, earth also will be pushed away from sun with the same force, right? Because the charges are same. So this q also, electrostatic force, as much is electrostatic force, let me write Fe, electrostatic forces will be same only. Now the thing is, the question asks, what should be q so that the Coulomb's force is just cancelled. Coulomb force just cancels the gravitational force. Now both are having huge masses, right? Let us say Sm is the mass of sun and Em is the mass of earth. Now because of these huge masses, gmm by r square, there will be one gravitational force of attraction as well, right? Now this is gravitational force of attraction. Now what should be the charge so that this gravitational force is just cancelled is the question, right? Finally it is given, this charge corresponds to how many free electrons. So as I said you in a question, what is given, what is asked. If we can write that, then that's the complete understanding of the question. So in this question, what is given? Now given mass of sun, I hope simultaneously you are having the question in your hand, so that whatever I am reading, you are also reading simultaneously with that. You are just not looking at the board without any understanding kind of thing. So what is given? Mass of a sun is given, that is how much? 2 into 10 to the power 30 kg. Then mass of earth is given, mass of sun. Okay, let us write this way. Mass of sun is this much. Mass of earth is equal to how much is given? 6 into 10 to the power 24 kg. G is given 6.67. So what question I gave you in that, G is not given. Actually it is just copied from a book, so G is not given, but This we should remember, 6.67 into 10 to the power minus 11. What should be the unit? Newton meter square per kg square. See, you remember, I didn't remember this. I didn't take it by heart. Where from I remembered this immediately? Now, F is equal to G m1 m2 by r square. This is the formula. So, G is equal to F r square by m1 m2, right? That's why F is measured in Newton, r square is meter square, Newton meter square per kg square. This is what I remembered. Okay, now what else is given? Number of charge. After calculating the Q charge, then Q is equal to NE, quantization of a charge, right? So implies that we can calculate the number of electrons. N is equal to Q by E. That N also is asked. This much is the question. So what is asked? What is Q? Q is equal to what? That also is asked, and N is equal to what? That also is asked. These two we need to find out. This is the question part, and we will see the solution. Okay. Now see, here clearly it is given directly that what should be the Q, so that Fe will be cancelled by Fg, or Fg and Fe will cancel each other. Now it is given directly, nothing much. Fe is equal to Fg. When this is possible is the question. Now what is Fe? Fe is equal to 1 by electrostatic force, right? 1 by 4 pi epsilon naught. Q1, Q2, both are having same charge. Let us say Q we have said. So Q square by R square. R is the distance between them. This is not given, that's why we wrote R only. It's equal to Fg is equal to what? G m1 m2, mass of sun multiplied by mass of earth, G m by r square. Again, distance between, square of the distance between them for gravitation. Newton's law of gravitation also says that this r square got cancelled with this r square, right? R square got cancelled with the r square. Now implies that 1 by 4 pi is the red visible. 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. Q square is equal to G equal to 6.67 into 10 to the power minus 11. Then simply mass is given. Mass is given. You have to put only in this equation. So ms is equal to how much is given? 2 into 10 to the power 30 multiplied by me. How much is given? 6 into 10 to the power 24. So Q square is unknown. So Q square is equal to by 9. This will go down, and Q is equal to root under that much. So what is the charge? I have checked these questions myself, and the answers given there are very correct. So Q comes equal to 229.8 into 10 to the power 6 coulomb. This comes Q. So once we got the Q, after that this much is equal to Ne. Now from Q is equal to Ne. Q is equal to Ne. This came from what? Quantization of charge. You remember Q is equal to plus or minus Ne. So Ne is equal to charge, total charge divided by charge of one electron. So this charge, total charge, how much we got now? 29.8 into 10 to the power 6 divided by charge of one electron is how much? 1.6 into 10 to the minus 90. And that number comes 1.86. Now I am just copying this number, but you will do it yourself, not using calculator. 1.86 into 10 to the power 36. And I had rechecked that these answers are correct. Okay. So we are moving to the question number 16 of assignment to 1.2. Two identical helium filled balloons A and B fastened to a weight of 5 gram by threads float in equilibrium as shown in the figure. Calculate the charge on each balloon assuming that they carry equal charge. Okay. Now two helium filled balloons A and B Two helium filled balloons A and B. Two helium filled balloons A and B. A and B fastened to a weight of 5 gram. This is 5 gram is the weight by threads float in equilibrium as shown in the figure. There is a figure where the things are mentioned. The distance between the two are given to be 0.6 meter. You might be seeing the question is in your hand, I hope. This is 0.6 meter. This each thread is given to be 1 meter long. Now this point is O. This point, name of this point is O. Now from there, if we drop one perpendicular here, this one imaginary line, okay, this line is not there in fact, just imagine one line. So if this total distance is 0.6 meter, from here to here, instead of saying here to here, let me take some name. Let us say this is C. Let us say this name is O, this point is C. Then CB is equal to half of 0.6, that is 0.3 meter, right? Calculate the charge on each. Two identical filled balloons fastened on weight threads float in equilibrium. Calculate the charge on each balloon, assuming that they carry equal charges. Okay, they carry equal charges, it said, but it didn't say what is the charge. So let us say both are carrying charges small q. Okay, this is our assumption. Now it is asking calculate the charge on how much is equal to q is the question. So whatever is given, that we have written on this diagram only. Now what is asked, q is equal to how much? This is a. Now see, there is a little concept here to be understood. Now this mass is floating in air, that means it is already in equilibrium. Now see, when it is in equilibrium, this thread is pulling it upwards, that's why it is in equilibrium, right? So tension is in this direction, yes or no? Let us say that is tension T. And in equilibrium, it is making an angle of a theta, let us say. Understand this concept very nicely, because the examiner will play around with this side, that side little, but the concept will remain same only. So if this is theta, then this tension in the string T can be resolved into two components, right? This total T, this side it will be T cos theta, and this will be T sin theta, yes or no? Now this side also, there will be one tension in the string. Okay, now what I am doing is I am thinking of the free body diagram of O. See, free body diagram of O we are considering. Okay, now this O point, free body diagram of O, this O point, it is experiencing a force in downward direction that is equal to its own weight, that is mg. At O is pulled with mg, and this side there is one force, tension, and this side also there is same tension, right? Now this tension can be resolved into two components, right? See, this is, if this is making theta, then this tension can be resolved into two components. This is T sin theta and this is T cos theta. Similarly, this tension also can be resolved into two components. If this is theta, this is theta, because it's in equilibrium, T sin theta, and this is T cos theta, another T cos theta in the same direction. So I am writing 2T cos theta. Now since this point O is floating, it's floating, that means it's already in equilibrium, it's not coming down or going up. So the upward force must be balanced with the downward force, yes or no? That's why 2T cos theta is equal to mg. Got or not? Let us make some drama. Let us make it equation 1. 2T cos theta is equal to mg. Now again you see that if you see any one of the balls, Q, let us say. Now this is, both charges are of equal nature. That's why they will push each other, yes or no? Now if you are thinking of a B, this is pushed in this direction with the force, electrostatic force of a repulsion Fe. Like that, A is pushed away with the same force Fe. Now this force, since this is an equilibrium, can we say this force must be equal to T sine theta? Now see, as I said, this T also will be derived, the one T sine theta, this also can be resolved, this T also can be resolved into two components, T cos theta, T sine theta. Now this T sine theta will be equal to this Fe, T sine theta will be equal to this Fe. So T sine theta is equal to Fe will be one equation, yes or no? So T sine theta is equal to Fe. See, if there are different types of forces, we have to specify electrostatic force. Now only electrostatic force, so F only I am writing. Okay, let us say this is equation 2. Now what you do, equation 2 by equation 1, if you do equation 2 by equation 1, what you get, T got cancelled, sin theta by cos theta is equal to tan theta and 1 by 2. So tan theta by 2 is equal to, tan theta by 2 is equal to F by mg. Yes or no? Understood this concept very nicely. Now see, F is known or unknown. It is known in terms of a Q, 1 by 4 pi epsilon naught Q1 and Q2 by R square. R is given. Mg is given indirectly. 5 gram means what? Okay, let me write it. I'll erase this part. You understood it, right? I am erasing so that I can continue. Here I can adjust. Now see, implies that here tan theta is unknown as of now, but indirectly it's given. You see, in the triangle, again in triangle, let us say OCB. This is a right angle triangle we are seeing, right? OCB. In this triangle, apply Pythagoras theorem. BC is equal to 0.3 meter, right? From B to A, this entire thing is 0.6 meter. So this much is a half of that, 0.3 meter. BC is 0.3 meter, and OB is given 1 meter in the question. So sin theta is equal to how much? Right? Sin theta is equal to P by H 0.3 by 1, that is 3 by 10, isn't it? If sin theta is equal to 3 by 10, then cos theta is equal to how much? Cos theta is equal to root under 1 minus sin square theta. We have a formula, mathematics, right? Sin theta is 3 by 10, so 9 by 100 this is. So cos theta comes 1 minus 9 by 100. 100 take LCM, so 91 by 100. So this is equal to root 91 by 10. Right? So if we got sin theta is equal to how much, cos theta is equal to how much, then tan theta we got, right? This by this is equal to tan theta. Implies that tan theta is equal to sin theta by cos theta. 3 by 10 divided by root 91 by 10. This 10. So tan theta also indirectly we got from this diagram. So tan theta we got, 2 is a known quantity. Then implies that what we can say, tan theta, how much it came? 3 by 2 into root 91 is equal to, so tan theta by 2, left hand side, F is equal to 1 by 4 pi epsilon naught Q1, Q2, both are Q, we took Q square by R square. R square is how much? 0.6 whole square, right? 0.6 whole square divided by mg whole divided by mg. Mg is how much? 5 gram, means 5 into 10 to the minus 3 kg multiplied by 9.8. So if we will solve this for 1 point, implies that 3 by 2 into root under 91 is equal to 1 by 4 pi epsilon naught is 9 into 10 to the 9, we know, right? Q square by 0.6 whole square into 5 into 10 to the minus 3 into 9.8. So if you solve and find out a Q from here, it is coming, the answer is coming, what is given in the question, plus or minus 5.6 multiplied by 10 to the power minus 7 coulomb is coming. Now see, there is one trick. I have said you many times last year also, you will not solve these things till the end point. Okay, because there may be several questions, several points which can be just cancelled out. You have to be a little smart. Another thing is, see here, q square is equal to 3 into this much divided by 9 into 10 to the 9 will come. So if our plan should be, if q square is equal to something square, if we can write like this, then q will be equal to this something. So that way, wherever squares are there, you don't multiply that thing, keep it square only. And if something is not in square form also, and if it is possible, you make it a square. For example, here 9 is there, like that as a 3 square, you write that thing. So basically our idea is q square is equal to something square should come, so that q is equal to that something we will find out. Is the idea clear? Here I'd like to say something. I got one similar question in SC Burma I saw, but there we should be a little more cautious, because in that question you see it was given something like that. There is a wall, and here there is a charge. A charge is given to a ball, and the question is something like this. There is one electric field in this direction, E, and that is pushing this, a plus charge is given, that is pushing this. And here why I said this thing is, here if we want to apply this, now see here also there will be mg if mass of this block is m, and this is coming in this direction, so Fe, electrostatic force, will be posed here. But here if in equilibrium this angle makes theta, then tan theta is equal to Fe by mg will make here. Or in the tension concept, if you see, this tension can be resolved into two components. This is again, if this theta, t cos theta, and this will be t sin theta. Now in this kind of a questions, when there will be one ball and it will be given some charge, and by one electric field it will be pushed. Now here it was pushed by a charge, here it is pushed by one electric field E, right? Now the thing is, here you see, just to bring it in equilibrium, F is equal to t sin theta. This concept was same as the previous concept. Here also t sin theta is equal to Fe we took. But here t cos theta is equal to mg. Whereas in the problem what we had given, t cos theta plus t cos theta, 2t cos theta was equal to mg. So that's the difference. Here 2t cos theta was mg, here t cos theta is equal to mg. So if your concept is clear, you do not remember that as a formula, that t cos theta will be mg, like that you never remember that, because in some case it is, see here in this 2t cos theta is equal to mg, but in different question there may be t cos theta is equal to mg. So always we will put the idea of neutralizing. If a body, if something is in equilibrium, then total upward force is equal to downward force. So we will put that concept only. Whatever is the total upward force, that will be equal to mg. Fine. Now we will shift to the next question. This is question number 17 of assignment 1.2. Two equally charged particles held 3.2 into 10 to the minus 3 meter apart are released from rest. The initial acceleration of the first particle is observed to be 7 meter per second square, and that of the second to be 9 meter per second square. If the mass of the first particle is this much is given, what is the mass? Okay, fine. Two equally charged particles. See, it's not given to identical particles. Two equally charged particles means the charges only are same. Let us say this is one particle and this is one particle. They are equally charged. So let us say Q, both are having same charge only, but they are not identical. Their masses may be different. Let us say one is m1, one is m2. Two equally charged particles held, the distance between them is given, right? So distance between them is given, and how much is that? 3.2 into released from rest. The initial acceleration. Now in which direction the acceleration will be? Now see, since this both charges are of equal nature, they will repel each other, isn't it? So this will move this way and m2 will move this way with some acceleration, and it will experience a repulsive force, and the same force will be experienced here. Now let us say this is moving with the acceleration a1 and this is moving with the acceleration a2. y1 2, this is first particle, this is second particle, like that. 1 and 2 we are taking. Mass also m1 m2, acceleration is a1 a2. Only charges are same, it's not q1 q2, it's a q only. Now I repeat reading this question. Two equally charged particles held 3.2 into 10 to the 3.2 multiplied by 10 to the minus 3 meter apart are released from rest. The initial acceleration of the first particle is observed to be, okay, a1 is given, how much? 7 meter per second square, and that of the second to be a2 also is given, 9 meter per second square. If the mass of the first particle m1 also is given, m1 is equal to 6.3 into 10 to the power minus 7 kg. If the mass of the first particle is 6.3 into 10 to the power minus 7 kg, what are, now the questions, what are the mass of the second particle? m2 is equal to how much? This is asked. Also asked the magnitude of the charge of each particle, the mass of the second particle and the magnitude of the charge of each particle. Q also is equal to how much? It is asked. Okay. Now see, this much are given and asked. Now see, this force of repulsion, this force will be equal to, this force will be equal to mass of this particle multiplied by acceleration m1 a1, yes or no? Similarly, this force will be equal to m2 a2, but this force is equal to this force because the same force of repulsion, right? So m2 a2 implies that since m1 a1 is equal to m2 a2, now of this what is given, right? m1 is given, a1 is given, a2 is given, m2 we have to calculate. m2 we can conclude that from m1 a1 is equal to m2 a2, so m2 is equal to m1 a1 by a2. So this is equal to m1 given 6.3 into 10 to the power minus 7, a1 is given 7 divided by a2 is given 9. So find out what is m2 is coming, 4.9 into 10 to the power minus 7 kg. Now see, 10 to the minus 7 is there already, so 6.3 into 7 by 9 is coming equal to 4.9, right? So m2 got how much? m2 is coming 4.9 into 10 to the power minus 7 kg. After that, what is q we'll find out. Now you consider, you focus on this much of the equation, F is equal to m1 a1. Now F is equal to how much? Coulomb's law, 1 by 4 pi epsilon naught q1 q2 q square by r square, square of the distance between them, 3.2 into 10 to the minus 3 whole square. This much is equal to F is equal to m1 a1, m1 is given, a1 is given 6.3 into 10 to the power minus 7 multiplied by 7. Now see, again you remember the same concept, squares are there means you keep it, you don't you keep it squares only because q square is equal to something square. If you get q is equal to that something, we can take it easily. And for 1 by 4 pi epsilon naught we will take 9 into 10 to the power 9, 9 into 10 to the power 9 q square by this, I am not writing again, 3.2 into 10 to the minus 3 whole square is equal to this much. Then q square is equal to something, you find out q is equal to root under that much. Then you find out how much q is coming. It is coming 7.1 into 10 to the minus 11 coulomb. Remember, I have done all these calculations in my paper and confirmed that whatever answers are given in the question are exactly coming that much only. Okay, so there is no way that some answer is mistake or something like that. It was copied from a book, but today before saying this I checked it myself in the paper and confirmed that these answers are correct only. So you solve it very nicely, you will get there only. How to solve that I am guiding. I hope this much is okay. Rest remained only the calculation part which you will do on your own. we are moving to the next question, that is question number 18. Okay, the question number 18 says a particle of a mass 10 to the power minus 4 kg and charge 5 microcoulomb is thrown at a speed of 20 meter per second against a uniform electric field of a strength 2 multiplied by 10 to the 5 Newton per coulomb. How much distance will it travel before coming to rest momentarily? See, this type of questions we had done last year only, but here electric field and a charge, that additional thing is involved over here. Power minus 4 kg and charge is given to be 5 microcoulomb, that is 5 into 10 to the power minus 6 coulomb, is thrown at a speed of speed is given 20 meter per second. Now see, it is thrown at 20 meter per second, but after some time it comes to rest. So final velocity is 0, initial velocity is 20 meter per second. 0 meter per second or simply 0. Acceleration we don't know. How much distance will it travel? Now listen, understand this question. Let us say when you throw something and it will come to rest against some force, if you are throwing, then only it will come to rest, right? There is one electric field. Let us say this is the direction of an electric field. Now along the electric field, if you put one positive charge, that will be moving along the field, yes or no? Why? Remember, if electric field is coming always from positive to negative, so this side is positive side, this side is negative side. If we are taking a positive charge, then that will be pushed by this, right? If you are taking a negative charge, that will be pulled by it. If we will take a positive charge, that will be pushed by it. Now if this plus charge, if you throw towards it against the electric field, if you throw, then since you throw with some initial velocity, it will go, but after some time it will come to rest, right? So the same thing, it's not adjustable here, that's why I am drawing it here again. Let us say this is the electric field. Now there is a particle, okay, that particle is having mass this much, mass is given, it is bearing some charge, the charge also is given, and that must be positive charge because it is thrown against it, right? Only if a negative, if it's a negative, it will be dragged by E, so it's not against. Against means it has to be positive, and the charge is given. It is thrown with a speed of 20 meter per second. When you throw it with 20 meter per second, it will go, and since it is pushed by the electric field, it will come to rest before coming back. It will come to rest and come back. Momentarily it will come to rest and it will come back, right? That's what it is asking. After traveling how much distance will it travel before coming to rest momentarily? So let us say it covers s distance before it comes to rest. So v becomes 0 after traveling s distance, let us say. Okay. Now solution part. Now see, what is force? F is equal to EQ, is the magnitude, you remember? So E is given in the question somewhere. E is not given or what, then we will keep in E only, but I think E was given in the question. Yes, E is given. A particle of mass 10 to the minus 4 kg and charge 5 microcoulomb is thrown at a speed of 20 meter per second against a uniform electric field of a strength. That's given. E also is given here. E is equal to 2 into 10 to the power 5 Newton per coulomb. It's given. Now F is equal to E into Q here. Okay. F is equal to E into Q. E is given 2 into 10 to the 5 multiplied by charge is given Q is equal to 5 into 10 to the minus 6. So it's Newton per coulomb and it's coulomb. Coulomb got cancelled. It becomes Newton. It's so easy numbers that orally you can solve it, right? See, 2 into 5 is a 10 and this is 10 to the minus 1. So 10 into 10 to the minus 1, 10 by 10 equal to 1 Newton. force is equal to mass multiplied by the acceleration of it, right? Now see, this force is in this direction and you are moving in this direction. So the displacement is in x direction, in along eastward, let us say, along x-axis, and force is in reverse direction. So this is -1. So we can say force F is equal to, from Newton's law, from F is equal to m into A. A is equal to how much? F by m. Now F is equal to -1 Newton, -1 by m is given somewhere 10 to the power -4. All numbers are given in such a way that you can do it orally almost, right? So A is equal to how much? 10 to the power of 4. So 10 to the power minus of 10 to the power 4. What's the unit of acceleration? Meter per second square. Now why it is minus? It is in fact acceleration is a minus, means it's a retardation or deceleration. It is coming, it will, after some time it will come to rest. That's why. If it's retardation, then only it will come to rest, right? If it's acceleration, its speed will be increased further. Since it is a minus, it is at 20 meter per second, but after some time it is becoming 0. Now from, some of you might have understood already how to solve, but I'm saying for everybody. Now from or now applying v square minus u square is equal to 2as. This we have done many times last year, right? So from there, what we can find out, see, v is there, finally it will become 0, u is 20 meter per second, a we have calculated just now, s only is not there. So s is equal to v square minus u square by 2a. So v square is 0, 0 square, finally it comes to 0, right? 0 square minus u square, it is 400 divided by 2a, minus 2 into 10 to the power 4. So minus minus got cancelled. It's 4 into 10 square divided by 2 into 10 fourth. So 2 2's. The numbers should be given in such a way that the calculation should take very less time, in fact, in questions. So here orally only you can say this will go back 2 into 10 to the power minus 2. So answer is 2 into 10 to the power minus 2 meter, that is 10 to the minus 2 meter should be the answer. Hope it's very clear. So all the questions you should solve yourself first. Make it a habit everywhere, every time. If you are getting one question, you solve it yourself. Even if it is not solved, spend some time with it, thinking this way, that way, all the things. And only when you cannot and you are reaching your end of your thinking, then only you look at the solution somewhere. So if some question comes in the, for example, 1.2 assignment, I'll be continuing further, giving more and more questions also. But what questions I'll be collecting, gradually you will see that the difficulty level will be increasing, which may be for JEE mains and the advanced, it will happen. But for everybody, what is mandatory part, I am saying, assignment 1.1, everybody must complete. And assignment 1.2 also, first 2 pages everybody must complete, and after that it depends how much time you can invest for physics. So hope it's fine as of now. Thank you everybody.